So here we go. Let's get started. Today we're going to talk about students will learn strategies for factoring as a tool to help them solve quadratic equations. With this, students will be able to describe what a solution means to a quadratic. Here's the thing. We're not only going to deal with just quadratic equations, we're going to talk about factoring lots of different types of equations. We're going to do quadratic today. Tomorrow we'll look at other types of functions that we can factor. The purpose is to learn how to solve these equations. Factoring is to help us solve an equation. So let's go to the first page of notes. So what is a factor? Talked about this a little bit yesterday. What is a factor? A number that divides into another number. The straight definition is writing an expression as the product of two or more things. Terms. Products. What is foiling? No, it's not solving it. What did we do? Yes, sir. First, outer, inner, last. First, outside, inside, last. Simply put, distribution. Done with multiplying two binomials. A binomial is a polynomial with two terms. So if I have something like this, it's our way of multiplying this out. First, outer, inner, last. First, outside, inside, last. Yes, sir. All right, so here we go. We talked about factoring, talked about foiling. How are they connected? What's the connection between factoring and foiling? Michael? Factoring is pretty much unfoiling. I'm undoing the foiling process. That's the whole reason why these are talked about together, because one undoes the other and vice versa. So here we go. Always factor out the greatest common factor first. Always take out a greatest common factor first. If there's a greatest common factor, always take it out first. Did I say that enough? I hope so. One more time. If there's a greatest common factor, always take it out first. So here's my question. 4xy squared plus 16x squared y. Is there a greatest common factor? 4x, y. Remember, when I'm factoring things out, it's really like I'm dividing them out of these terms. And what I have left goes inside the parentheses. The plus stays in the middle. What am I left with in the first term? What happens with my 4's? 4's cancel. X's, y squared divided by y, just one y. Okay. 16 divided by 4, 4. X squared divided by x, y divided by y, cancels out. Y plus 4x. Can I factor out y plus 4x anymore? No, this is fully factored. Okay. Do you need to see another example? Example 2. Okay. Same thing. What's my greatest common factor? Look at the numbers first. What divides into 16, 4, and 12? 4. So I'm going to take out a 4. What divides into a squared, and a to the 4th? A squared. What divides into b cubed, b, and b to the 4th? 1b. 1b. What's left over? So one more time, I took out a 4a squared b. What's left over here? Not just 4b, but 4b squared. I took out 1b, there's 2 b's left. Minus. Took out a 4b squared. Excuse me, 4a squared b. What's left? Nothing. It's not nothing. There's 1 left. Remember, these are dividing out. They're not subtracting out. So you're not going to be left with 0. You're going to be left with 1. How about here? What? 3a squared b to the third, or b cubed. Greatest common factor. Greatest common factor. Because if I divide this by 4a squared b, I'm left with 1, and there's a minus in front of it. Okay? God bless you. Any other questions? Can I move on? Yeah. Factoring quadratic polynomials. Quadratic means it's degree 2. It has an x squared or a y squared or a k squared in it. Factoring out a second degree polynomial, there's different methods. The first method, the quadratic trinomial, has a leading coefficient of 1. Now we have guess and check. Do we really want to guess and check here? Okay. We're not going to guess and check. We're going to use what? We're going to use what in another class I call basic factoring. Some people call this the diamond method, the cross method, whatever method you want to. When I do it, I ask the question, what multiplies to be 12 and adds to be 7? I use a table because if you really need to, you can list all your factors. Which of these? 4 and 3. So then I have x plus 3 times x plus 4. Okay? This is the most basic kind of factoring. Yes, sir. Yes, sir. Step by step, as I ask myself the question, what multiplies to be 12 and adds to be 7? Because when I unfoil, I want to find two numbers that last will multiply to be 12. That inner outer will add to be 7. I'm unfoiling, literally. 3 times 4 is 12. 3 plus 4 is 7. If it fits that pattern, this is my answer. I use the numbers that don't have the exponent because the number in front of the exponent is 1. Okay? Number 2. I want to do the same thing. Same pattern. What multiplies to be negative 35 and adds to be negative 2? Okay. You could list all the factors if you want. 1 and 35. 5 and 7. That's all of them. 5 and 7, I can have a difference of 2. Which one needs to be negative for it to be a negative 2? The larger one, the 7. Again, what multiplies to be negative 35 and adds to be negative 2 is going to be 5 and negative 7. I'm running out of time. Let's go a little faster, please. Yes, sir. Yes. No, that's not our answer. What goes right here? M's, not X's. It should be M's and not X's. So if I FOIL this out, do I end up with the original answer? Yes. First, m times m is m squared. Outer, m times negative 7 is negative 7m. Inner, 5 times m is 5m. Shh. 5 times negative 7 is negative 35. Look what you've got right here. When I FOIL this out, do you see that's the two numbers that I chose over here? That's purposeful. I'm unfoiling when I factor. You need to see and make that connection. Do I need to do 3 and 4? Does anyone need to see 3 and or 4? Okay. Shh. Here we go, number 3. Again, you have to ask the same question. What multiplies to be 18 and adds to be negative 11? Most of us can think through these factors and come up with what they are. Some of us need to list the factors. I like to keep them in order. Now the thing about it is I need a positive 18 and a negative 11. So both the 9 and the 2 have to be negative. Number 4, t squared plus 4t plus 12. Same question. What multiplies to be 12 and adds to be 4? 1 and 12, 2 and 6, 3 and 4. It's a positive 12 and a positive 4. Can I have anything that's negative? No. Is there an answer? This is not factorable. Is it solvable? Yes. But it is not factorable. There's a difference. We're not looking for solutions right now. We're looking for factors. This will be solvable. Everything that we do quadratically will be solvable. But it is not factorable at this time. Okay. Again, we went over this quickly yesterday. Let's do this one more time. Now, I'm going to end up with a number in front of my x squared. It's not going to be a 1 in front of the x squared. I'm going to have something else. Always I take out a greatest common factor if there's a greatest common factor, but my leading coefficient is not 1. The method I showed you yesterday is California method. This is not the only method, but it is the one we teach here. Example 5. Is there a greatest common factor? No. Number 5, number 5, number 5. The thing about a problem like number 5 is I have to take into account not only the C, but the A when I do my multiplication. So instead of this just being a C and the B, what adds to be 9 and multiplies to be negative 18, I need to multiply the 2 and the negative 18. I have to take that 2 into account. And to take it into account, I'm going to multiply it by the negative 18 and get negative 36. And now the question is still the same. What multiplies to be negative 36 and adds to be 9? Again, as the math teacher, I like to list all my possibilities. Five won't work, 6 and 6. Okay. Do I need to make at least one of them, if not both of them, negative? One or both? One of them. Okay. I want them to add to be 9. The 3 and the 12 look good. Since I want it to be positive, it's the 3 that needs to be made negative. But remember, this is the part that's different. I can't go straight to my factors at this point. Stay with me. I can't go straight to my factors at this point. At this point, what I need to do is I need to take this 2 into account. And so I'm going to put 2x over my first factor and 2x over my second factor. My expectation is at least one of these will reduce in some way. At least one of these will reduce in some way. My first term does not reduce, so I get 2x minus 3. My second term does reduce, x over 6. So that's x plus 6. Okay. So, again, this is my answer, 2x minus 3 times x plus 6. If you don't believe me, how do you check it? You FOIL it out. And when you FOIL it out, you should end up with 2x squared plus 9x minus 18. Okay. Example 6. Is there a greatest common factor? Yes. What is it? It's y. 4y squared minus 17y plus 15. If I do not take that y out, is this factorable? Have I taught you how to factor a y cubed yet? No. So you have to take out a greatest common factor first. Now that I've taken out the greatest common factor, I can create my little table. And again, the question remains the same. I need to multiply the 4 and the 15. What's 4 times 15? 60. What multiplies to be 60 and adds to be negative 17? Justin has all the answers. Again, as a math teacher, I can list 1 and 60, 2 and 30, 3 and 20. That's another possibility. 4 times what? 15. 5 times 12. 6 times 10. 7 doesn't work. 8 doesn't work. 9 doesn't work. That gets me back. So notice here I have two possibilities. 3 and 20. 5 and 12. I want a positive 15 and a negative 17. So which is it? Okay, so it's negative 5 and negative 12 to multiply to be a positive 60 and add to be a negative 17. But some of these might have two possibilities I have to test. So I come back, and again, I have to do the whole fraction thing. 4y over negative 5. 4y over negative 12. My first factor is that y in front. Does 4y over negative 5 reduce? So this is 4y minus 5. Does 4y over negative 12 reduce? Y over what? Negative 3, 1/3. So this is y minus 3. Multiply it out, FOIL it out if you don't. Just like yesterday, I can also have special factoring patterns. All of these patterns come from the fact that we're unfoiling. When I FOIL, I get special things happening, and sometimes it works and sometimes it doesn't. Difference of squares. when I have x plus, give me a number, 7 times x minus 7, and I FOIL this out, what's going to, since these are opposite signs and everything else is the same, what happens to my inner and outer? They're going to cancel. If I FOIL this out, first is x squared. Outer is negative 7x. Inner is positive 7x. Last is negative 49. Notice the pattern. The middle two terms cancel. The first term and last term are both what? Perfect squares. Okay? Those canceled out. So if I look at example 8, I want to go backwards. Is this a perfect square? What? X. Is 81 a perfect square? What? 9. Is it subtraction in the middle? Yes. So this is my conjugates. When I have the same two factors, the only difference is plus or minus in the middle. These are called conjugates. Now here's the thing about this. Will this work if it has plus in the middle? As of right now, no. If something special happens when there's plus. Right now, we're not going to worry about it. That's a difference of two squares. But there's another type of special pattern that we can talk about, and this is called a perfect square trinomial. When I did my example up above, I did x plus 7x minus 7. What if I was multiplying and I had x plus 7 times x plus 7? They're identical. There's nothing different whatsoever. Well, when I FOIL, my first is a perfect square. My outer and inner are identical. My last is a perfect square. So I get a perfect square in front. I get a perfect square in the end. What do I get in the middle? Twice my original number. Instead of 7x, I get 14x. I get double the amount. And this is another pattern. So if I look at number 9, is x squared a perfect square? Yes. Is 16 a perfect square? What? 4. If I multiply and double, do I get the middle term? Yes. So that's my answer. If I multiply and double and I get the middle term, that's my answer. How about this last one? Quickly, what do you think it's going to be? X, 7. If I multiply and double, do I get the middle answer? If it's negative, I sure do. If it's negative, I sure do.